Hello everyone and welcome back to our channel mootechie. It's great to continue our exploration of dairy engineering with you. This is class 7 in unit 4 where we will now delve into the different types of sterilization processes, building on the fundamental principles we covered in our last session. We'll begin by categorizing sterilization processes. Sterilizers are broadly divided into two types: batch systems and continuous systems. Batch processes typically involve sterilizing the product inside its container, such as in a can or a case. Continuous processes often involve heating the product before packaging, using methods like the injection of steam directly into the product or the infusion of the product into a chamber of steam. Let's first focus on batch sterilizers. There are several kinds, including rotary or full immersion sterilizers, agitating retorts, water processing retorts, and crateless retort systems. These retorts can be oriented either horizontally or vertically. A common example of a batch sterilizer is the autoclave, also known as a retort. A vertical retort has various ports for introducing steam, water, and air. It also has ports for venting and a constant steam bleed. A relief valve is a critical safety component. The autoclave or retort is controlled by a system that manages air, steam, and water. It is equipped with a pressure gauge, a temperature recorder, and a safety valve, often with a bypass. The working of a retort involves a specific cycle. The process starts with venting to remove air, ensuring only steam is present for effective heating. Then the temperature and pressure are increased and held for a set time before cooling begins. This cycle can be seen on a time temperature profile for batch sterilization. The temperature rises during the heating up phase to a target, like 121 degrees Celsius. It is held constant during the holding time, which is when microbial reduction occurs, taking the population from an initial level N1 down to N2. Finally, the cooling phase brings the temperature down, further reducing the population to N3. Batch sterilizers like retorts have distinct advantages and disadvantages. Their advantages include flexibility in handling different package sizes and relative ease in maintaining a constant temperature. However, the loading operation can be laborious, and heating can be slow, because there is often no agitation to mix the liquid inside the containers, leading to uneven heating. Now let's turn our attention to continuous sterilization plants. These systems are designed for high-volume production and include types like the Hydrostatic sterilizer, the Hydrolock sterilizer, and other continuous sterilizers. The time temperature profile for continuous sterilization is very different from batch processing. It features a very rapid heating phase, reaching a high temperature like 144 degrees Celsius for a very short time, perhaps only 20 to 30 seconds, followed by a rapid cooling phase back to around 27 degrees Celsius. This is known as a high-temperature short-time process. Continuous sterilizers can be designed as a continuous crateless sterilization line, where containers move through the system without being held in crates. One major type is the hydrostatic vertical sterilizer, also known as a tower sterilizer. It can process bottles made of glass or plastic. It operates under pressure, which is maintained by water legs or columns of water. This sterilizer consists of four main chambers. First, the hydrostatic come-up feed leg for preheating. Second, the sterilizing chamber itself. Third, the hydrostatic discharge leg for pre-cooling under pressure. And fourth, the final cooling section. A detailed diagram shows multiple stages. There are several heating stages, a sterilization section, and multiple cooling stages. The product moves through on upper shafts and wheels that are individually driven. Steam is used for heating and cooling water for cooling. The normal height of the water column needed to achieve a temperature of 121 degrees Celsius is about 13.7 meters, which is why these sterilizers are often very tall. A conveyor carries the cans through the steam chamber, and the sterilization time can be changed by varying the conveyor's speed. The system uses steam, hot water, and cold water sprays. The advantages of a hydrostatic sterilizer are its flexibility and high capacity. The main disadvantages are its great height and the associated high cost. Another type is the Hydrolock horizontal sterilizer. This is a rotary valve seal sterilizer designed for high-speed, short-time sterilization. It is a comparatively low-built machine. Containers enter and leave through a rotating pressure lock that is sealed partly by water and partly by mechanical means. In this system, bottles or cans are loaded automatically. A rotating valve simultaneously transports bottles into and out of the pressure chamber. They pass through the sterilization area, a pre-cooling area, and final cooling at atmospheric pressure before being unloaded from the conveyor chain. The sterilizing space contains a chain conveyor. A high water level and a low level create seals. The pressure chamber features a hydrolock mechanism with an opening for cans, and cooling water is managed by a divider. The advantages of the Hydrolock horizontal sterilizer include its lesser height compared to tower sterilizers, lower cost, and mechanical operation. A noted point is that may not be fully automatic. Finally, we have the horizontal continuous rotating autoclave. This system uses 3 cylindrical vessels. Each vessel contains a helical strip attached to a roller inside, which forms channels. These channels forward the cans along during processing, while simultaneously rotating them for better heat transfer. It also includes a double detector system to check for non-sterile cans, with one detector at the exit of the preheater and another at the end of the pressure cooler. Thank you for joining this detailed session on the various types of sterilization equipment.